Okay, let us consider a problem on Coulomb's law. First example, which says 2 point charges each of 0.65 microcoulomb are separated by a distance of 0.5 meters. There are three parts of this problem that has to be found out. First one, what is the force of repulsion? Second, what is the force of repulsion if each charge is doubled and the distance between them is halved? And third, what is the force of repulsion if the two charges are placed in water whose dielectric constant is 80? To find out the solution, I'll first consider these two charges which have charge equal to 0.65 microcoulomb. So according to this, both the charges Q1 as well as Q2 have a charge equal to 0.65 microcoulomb, which can be written as 0.65 10 to the power of minus 6 coulomb. And the distance of separation between both the charges is 0.5 meters. Hence, R is equal to 0.5 meters. I have to find what is the force of repulsion. So to find the force of repulsion, I'll consider first one, force F, which is given as 1 upon 4 pi epsilon naught Q1 Q2 upon R square. I'm substituting the values of Q1 Q2 as well as distance R and 1 upon 4 pi epsilon naught into the above formula, where on substituting and simplifying you should get an answer which is 1.521 10 to the power of minus 2 Newton. Moving to the second part, you have to find out what is the force of repulsion if each charge is doubled and the distance between them is halved, where again distance between the two charges is 0.5, value of the or magnitude of the charge is 0.65, and we have just found that force is 1.521. So now if this charge is doubled, it means and the distance is also halved, it means the force now can be written as F dash is equal to 1 upon 4 pi epsilon naught 2 Q1, since charges are doubled, into 2 Q2 upon distance, which is halved, should be written as R upon 2 the whole square. Simplify this relation to get 1 upon 4 pi epsilon naught Q1 Q2 into 4 upon R squared upon 4. You can now easily shift the 4 which is in the denominator to the numerator to get an answer which is 1 upon 4 pi epsilon naught Q1 Q2 upon R squared into 4 into 4 will give you 16. So I get F dash is equal to 16 times the original force, or 16 times 1 upon 4 pi epsilon naught Q1 Q2 by R squared. In the previous section we have found out what is the value for force, which is 16 into 1.521 10 to the power of minus 2 Newton. So your answer should be 24.3 10 to the power of minus 2 Newton. That is the second part of the problem. Going to the third part, we have to now find what is the force of repulsion if the two charges are placed in water whose dielectric constant is 80. Now since dielectric constant, which is given as 80, I can write epsilon R is equal to 80, that is relative permittivity, which is 80. Therefore the force now should be written as 1 upon 4 pi epsilon into Q1 Q2 by R squared, where epsilon can be replaced by epsilon naught into epsilon R. So this expression is now written as 1 upon 4 pi epsilon naught into epsilon R into Q1 Q2 by R squared. I can further write this expression as 1 upon epsilon R into 1 upon 4 pi epsilon naught Q1 Q2 by R squared, where we have found out what is the value for 1 upon 4 pi epsilon naught Q1 Q2 by R squared, which represents initial force 1.521 10 to the power of minus 2 Newton. Hence you can write the new force should be equal to the initial force divided by epsilon R. So I get 1.521 10 to the power of minus 2 divided by 80, which should give you an answer of 0.0190 10 to the power of minus 2 Newton.